So, good morning, everybody. I hope you have a nice day today, at least at the beginning. We'll see how it ends. Today, our topics is on integrated pest management with some additional focus on aquaponics. So last time you heard Zala talk about plant growth requirements and nutrient deficiencies. And the next one will be Michael Reuter, who will be talking about balancing of aquaponics. But today we focus on plants and IPM in these systems. So maybe you probably already know me. I'm Ranka Junge. I am Emeritus Professor of Zürcher Hochschule für angewandte Wissenschaften. And I did my PhD at University of Constance, and I specialized in the last 27 years, let's say, in wastewater fed, aquaculture, aquaponics, and so on. Our scheduled guest for today was Albert Fosso, who is United Nations FAO consultant. He also studied in Wädenswil, which I'm very proud of. But however, he actually sent me his presentation in PDF. But over the last 3 days, I contacted him repeatedly, and he doesn't seem to answer. So it seems that at the moment he's at Comoros, and perhaps they have problems. I suppose they have problems with internet connection, because otherwise he always promptly answered. So you are not going to see Mr. Albert Fosso. I am very sorry. Today we'll have a look, as I said, integrated pest management, then about integrated pest management in aquaponics, and then there is a massive, humongous homework to obtain ELISA certificate level 2. And for those who are not here and who will be looking at this as a video, this homework will be for the attaining level 1. So, what are plant pests and pathogens? It's organisms that directly harm plants either by consuming them or damaging their tissues. It can be the pest, it can be insects, but it can also be rodents, birds, or other animals. While plant pathogens are microorganisms like fungi, bacteria, viruses that cause diseases in plants by invading them and disrupting their normal functioning. One of the most well-known are fungi, for instance, powdery mildew, or bacteria with fire blight, or viruses, tomato mosaic virus, or nematodes, some nematodes. And what is integrated pest management? This is the pest management system that utilizes all suitable techniques and methods to maintain the pests at levels below those causing economic injuries. This is a very important point, because they do not want this pest management system, IPM, I will call it, is not meant to exterminate the pests. It is meant to keep them at a very low level. And in Europe, all professional plant growers need to apply the IPM since 2014. So it's a law. And in Switzerland, I think even longer. So there are 5 main elements of IPM. It doesn't matter in which one you start, it could be, you can mix them because they are all part of this, and it has to be iterated again and again. Definitely, I would say the first step is to prevent the spread of pests and diseases. Then constantly monitoring the pest population, identifying the pest and its abundance, who is there eating my crop, evaluate, based on monitoring results, decisions can be made. Is pest causing damage? Is it relevant? Is it time to act? And then action, reduce the pests below the economically damaging level. So let's look at prevent. Very important in prevention is hygiene of cultivation conditions. Before starting any cultivation, one needs to clean and disinfect everything, especially if you're working in greenhouse, because greenhouses have a special climate which is can be very conducive to massive development of pests if it is nicely warm, not too hot, nicely humid, So everything needs to be disinfected. There is a choice of suitable disinfectants, and also hands and shoes of workers and visitors in a greenhouse, should you have a greenhouse, should be disinfected. You need disinfectant foot mats. If you have a greenhouse, you need double doors, you need netting, and so on. Cultural prevention is one needs to remove the weeds in and around the area where you are cultivating your plants, use clean plants, and select pest and pathogen resistant varieties. Other cultural prevention includes crop rotation, not always the same crop at the same place, and polyculture. Or any type of polyculture like intercropping and so on. And then there is physical prevention. Prevent pests from entering the greenhouse. You can't prevent pests from entering open field, but you can prevent entering the greenhouse. But intercropping you can have in field, but also in greenhouse. Here you can see an example of this cultural prevention, intercropping of lettuce with some basil and with other herbs, with mint. Another cultural prevention is sacrificial planting or trap cropping. This is adding plants that attract agricultural pests as companion planting, and then the pests sit on them and not on your main crop. Here are some examples of plants that are widely used for sacrificial planting, like nasturtium or chervil or marigolds and nettles. Monitoring. So, the important parts of monitoring is that one is that you look at the plant practically every day, and it is important also that the parameters for plant growth are set within the optimum range of species being grown. Unfavorable conditions will change the performance of crops and also reduce their resilience. So I notice, like for example in my garden, if I plant a plant that likes sunny area of the garden and I plant it in the shaded area, it simply won't work. And there will be lots of aphids on that plant because the plant will be weakened. So you need to monitor closely, daily, the upper plants, the leaves, the roofs, and any signs of stress shows that there are some plant health issues or nutrient imbalances, which are sometimes hard to distinguish. But if you look closely, you will find the reason. And then you need to monitor environmental parameters in the greenhouse. Zala was talking about environmental parameters, so I'm not going to go here in the detail. You need to monitor relative humidity, air temperature, and light intensity so that they are in the proper range of the plants that you are cultivating. Now, for most vegetables, so if it's outside the proper range, you need to manipulate it, the temperature or the humidity or the light conditions. Manipulating humidity is usually by manipulating temperature or manipulating the airflow. Manipulating the temperature is you need again manipulate the airflow or add sprinklers or air conditioners or air heaters. And manipulating the light intensity means adding some lighting in certain parts. And then you have to monitor the insect population. Usually we use glue traps in early detection. You place the glue traps throughout your field or your greenhouse in the vicinity of your crop, and then you monitor what kind of insects are gluing on it. So there are actually 4 types of sticky traps. Yellow ones are for all kinds of insects. Blue are mostly for thrips. Black are for trapping tuta absoluta, which is a tomato pinworm. So if you don't grow tomatoes, you don't need necessarily those. And the reds are for leaf hoppers and gall midges. So one has to consult the website of, for instance, of BioBest and see what kind of traps are for what, but in doubt, you just at least put there some yellow sticky traps. And then whatever you have caught on your yellow sticky traps, you have to identify. And this is a problem by itself. So either you use some experts or you can contact perhaps like Coppert in your country or BioBest in your country, and they will have experts who will come. Or a good thing would be to get yourself this book, Knowing and Recognizing the Biology of Pests and Diseases and Their Natural Solutions. It's a very good book and helps in identification of your pests. You need to have some internal action standards to evaluate when do you want to start to act. But usually the pests in greenhouse are very quick in their spread, so you usually need to act quickly. You can't detect a pest and then start thinking for a week and then applying something. That's too slow. Because once you have lots, your pest has spread and is there in a big number, it will get more and more difficult to push it back to the levels below economic impact. So you have to act when there is still little pests there. And what kind of action do you have? So you can have biological control, like predators, parasitoids, and homopathogens, and chemical control, but that is only the last resort. And in chemical control, actually only pesticides derived from natural materials like oils, baking soda, are permitted in organic agriculture, and they can be used as a part of IPM as last resort. What you have to do at this point is consult your national legislation, because every country has a bit of their own legislation. So what is allowed, for example, in Switzerland, inputs that are allowed in Swiss organic agriculture can be, there is here a link, and this is uploaded annually and can be downloaded, and it is also for Germany and for Austria. But it doesn't mean that the same list is working in Norway, for instance, which is also not part of EU. They would have different regulations. And then I suppose Jordan and Ghana and Nigeria will also have different regulations. So you need to consult your national legislation. biological pest control is actually use of living natural enemies to control pests. This is sometimes not very easy to find, so there is, of course, a long list what is allowed. I have recently seen a very nice publication and a review paper in LinkedIn. I will maybe share it sometime separately, but there are tools then that you can use, I mean organisms. Against aphids, you use, for instance, lady beetles. There is a lady beetle eating aphids. Or parasitoid wasps or entomopathogenic fungi. Against mites, there are predatory mites. Against thrips, against predatory mites and predatory bugs. And against whiteflies, again, mice, bugs, and then parasitoids. There are companies that produce these animals they don't produce, they have to cultivate them and pack them in certain packages where you can use it. Oh, Mr. Albert Fosso joined us. I'm really glad. So great. Like, for example, predatory mites, they are then from BioBest, you can buy such sachets, which you then distribute along your crop, and they release slowly Ambliseus andersoni. So predatory mites can feed on alternative hosts when pest populations are low. So, and they can be put in greenhouse before the pests are present. Actually, they are kind of prevention, but biological prevention. And because they are small, they can only feed on eggs or small or young pests, which is very important. So if you have old pest population, this won't work anymore. You put in predatory mice before your pests arrive. A special system is banker plants. Banker plants provide alternative food source for beneficial insects and also reproduction site for them. So a banker plant system is a release system consisting of three elements: the plant itself, the alternative prey or food to sustain these natural enemies, and the natural enemies themselves. So these are plants that you can put in your system, and they will be a constant source of your biological. So instead of buying such systems in a pot or in a sachet, you can use banker plants to house constantly your main biological agent. One example are flowering banker plants. This is sweet alyssum, Lobularia maritima. Here is on the right is an example where they planted alyssum in a field of strawberries. In open, it's not in greenhouse in this case. This is how it looks like. It's a very common plant in gardens. You find it a lot in gardens in Switzerland. And it is a home for predatory bug like Orius, insidious. It's a small predatory bug, and they feed on small pests, arthropods, and their eggs. And you can use them for biological control of thrips. So in a greenhouse, you would have, I will show you now more banker plants. There are some more examples. For instance, against whitefly, you can use, this would be the bug that is natural enemy of the whitefly. It needs plant sap as food source, and the banker plant would be mullein, that's verbascum. That's also a very common plant. Actually, in some parts of the world, it's even invasive. Against thrips, you could also use not only alyssum, also as a host for Orius, you could also use some decorative peppers. It looks nice. and it hosts your bug. Against thrips, you can use pollen of ricinus, of castor bean, as a food for Ephesus. And against aphids, you can use as a cereal banker plant, you can use a cereal, oat or wheat, to host Aphidus colemani. There are companies that sell such little pots with, and then separately the food source, and then you cultivate the wheat with the food source, and then these Aphidius will grow here and on this and eat aphids. Where to place banker plants? So one thing was like the example that you have seen was in a strawberry field, just like intercropping. Or you place them throughout the greenhouse. For instance, you can hang the baskets so that they are a bit away from the crop and they don't disturb your work. Or you can put it in between, among the flowers, for instance. In certain, you have to decide how many you want. They should be replaced every few weeks because to be sure that you have enough, of animals. So these are actually all methods that could be also used in organic farming. So what would be the difference between IPM and organic farming? You can see that preventative methods, cultural and physical, are the same for integrated pest management and for organic farming. So crop hygiene, physical barriers, use of strong and resistant seedlings, hygiene measures at the entrance, no visitors, no problems. That's why we are rather restrictive with visitors in Wädenswil, restricting visitor numbers. So this is for both. Now, also use of beneficial insects against pests. The biological pest control is the same in both. You can use organisms for biological pest control in integrated pest management and in organic farming. Well, with chemical control, there is a difference. In integrated pest management, you are allowed to use synthetic pesticides not toxic to fish, especially if you have aquaponics, but only as a last resort. And use of natural pesticides listed under biological pest control is possible too. While in organic farming, only use of natural pesticides is allowed, like oils, potassium bicarbonate, and sulfur against powdery mildew and lecithin. However, you need to have a look at toxicity exposure ratio. This is here in the footnotes, because you need to see the predicted environmental concentration, and today's homework will be about that. So there are some parallels between integrated pest management and organic farming, but there are also some fundamental differences, and they are in the chemical control that you can be using. So, Mr. Albert Fosso.
Good morning, everyone. My name is Albert Fosso. I'm an international consultant of FAO in plant production and protection. Actually, I'm a consultant to FAO Comoros on plant protection and production. So I graduated in Wädenswil in 2004. After my graduation, I joined FAO from 2004 to 2005 in Rome, where I did my volunteer, like my internship. During the internship, I used to work on the FAO database, Ortiva. Ortiva is a database of FAO where we collect all the information of horticulture crops all over the world. We also produce card on good agriculture practice. So after my 6-month volunteer work to FAO, I was sent in Namibia in August 2005 to implement a government project, the Integrated Initiative in Support of Urban and Peri-Urban Horticulture in Namibia. It's a project of the government of Namibia with the technical expertise of FAO and funded by the government of Belgium. After in 2009, up to today, I become an international consultant of FAO in plant production and protection. In March, I've done a 1-year training with the Post-Harvest Education Foundation. Then I become also consultant on post-harvest. Can you continue the next slide, please?
Yes. Oops.
Can we continue, Ranka?
Yes.
The next slide, please.
Also the next slide. Okay. Objective of the project. So now I wanted to say this was like general introduction to IPM, what's the point and how it is going. However, in aquaponics specifically, it's a bit different because aquaponics is a very special growing system. There is no soil. This is like in hydroponic, no weeds, fewer above ground pests, no soil-borne pests and diseases, reduced pupation sites for some arthropods, but also it's very high humid environment because it's aquatic. There will be in hydroponic a lot of water, but also usually you have it near the water tanks of fish, so the whole situation is much more humid. And aquaponics is understood to be more resilient against pathogens when compared with conventional hydroponic production. It is nevertheless impossible to avoid pests and diseases. And the main limitation of the application of plant protection and fish medication in aquaponics is that everything is connected, especially in a closed aquaponic system where we have recirculation. That it is a problem. If we have a fish disease, like this poor tilapia here with Aeromonas, and we would use antibiotics, which we in Wädenswil would not, I must stress, antibiotics would be toxic for microbial community in biofilter and on plant roots and potentially could be toxic for plants. If we would have plant disease, like powdery mildew or something else, then if you would use fungicides, that would be toxic again for microbial community, which is central in aquaponics, and potentially toxic for fish. And if we use pesticides against plant pests, again problems with microbial community and toxic for fish. So this toxicity that using one wrong product on one side also kills the other side, this is a big problem in connected systems, in recirculating systems, and it has to be avoided at all costs. So the plant disease prevention measures in aquaponics are very important again, like in IPM. This table is just a, once again, iteration why this is also important and what is, it's actually a summary of everything we have talked about now. It's the same like IPM with additional respect for fish toxicity. Here is
Ranka, Albert is back. Albert is back.
Okay.
Albert, can you hear us? Okay, Ranka, then just continue, and then if we have time at the end, we try again.
Yes, I think so. Here is an example from 2014. This is actually the master thesis of Zala. Here is the reference. How she was using and what was she using during cultivation of tomatoes from March. So the cultivation period was from March to November, to the beginning of November. And you can see in March and in September and October, she was using nothing. But during summer, when the more sun and warmth and humidity there was in the greenhouse, the more stuff she had to resort to as prevention, like Encarsia and Ichneumons against aphids. And then she had to resort also to some chemical. You see, this is all biological crop protection and this is chemical crop protection because this was the last resort. Envidor, this is the absolutely last resort. You stagger your plant protection in a way that you use the most dangerous stuff in the end, and also that very carefully. So how do you go about this? Perhaps you live which is also one important point, is you need to consult experts. You cannot just throw something on your culture. You need to consult experts. In every country, there will be some kind of experts that consult farmers, and you need to consult them. Otherwise, you need to consult experts online if they cannot come and visit you. So, how to estimate if the plant protection product is suitable for aquaponics? First step is you consult your national legislation. Then you select the substance, whichever you would like to use. You gather the information about the selected substance. It is a part of safety data sheet, which the company has to provide for every substance that they are selling. And then you look at the environmental toxicity of this part, and then you estimate the critical mass of system loading. So how much could you use in your system? So the first step to study the safety data sheets, you go to the website of the supplier and look for the product. And you look also I said you studied the national legislation. This is an example for Ghana. Banned or restricted chemical pesticides are aldrin, dieldrin, endosulfan, lidan, DDT, methylbromide, carbofuran. So you're not allowed to use those at all. But then you look what is offered by different companies and look for the safety data sheets. You can use in Switzerland, you would use Andermatt, but there is also Andermatt Africa, for instance. There is ProGreen, there is Crop Science in many countries, BioBest is in many countries. Here is an example, not the entire safety data sheet, just little pieces. The entire safety data sheet, for example, for Batavia, is each data safety sheet has 14 sections. So one is identification of substance mixture of the company, then there is hazards identification, composition information, first aid measures, firefighting measures, accidental release measures, handling and storage, exposure control, personal protection, what do you need to use, physical and chemical properties, stability and reactivity. And then section 11, which is important for us, is toxicological information. This is important for humans. And then ecological information. So the ecological information contains information to toxicity to fish and toxicity for aquatic invertebrates. And the tests that were performed will be listed here, and the threshold measures will be listed also here. Then toxicity to aquatic plants. For instance, this Batavia has really lot information in safety data sheet. There are other safety data sheet where it's written for this, no data available. I will show you an example later. So you need, of course, to understand what is LC50, EC50, no EC, EC50, ER, against LG, against. And then the next section is persistence and biodegradability and bioaccumulation potential, and then there are other subsections in the end. So that would be example of a safety data sheet. Now I said you need to know what is EC50 and so on. We cannot discuss here the whole toxicity basics. You can Google that because there are very good explanations in internet. But normally, for every potentially toxic substance or for every substance, the toxicity is investigated by the dose response curve. It describes the relationship between the absorbed concentration and the extent of the toxic effect. So you measure the concentration, you have a concentration, the different concentration of a substance, and you give this, for instance, somebody to eat. Not a person ideally, but maybe, let's say, a rat. And then you see which percentage of rats will show a response, like sickness, for instance. Now, in organisms that live in water, you don't talk about the dose response curve, but we talk about effect response curve, because we cannot know what dose exactly, for instance, a water flea ingested when she is living in the water of certain concentration of this toxic material. So we talk about effect. We measure the concentration in the water and see the effect of the water flea, for example. And if the effect is death, then we talk about lethal effect. So that would be LC50. Here you see toxicity to fish, LC50 is to rainbow trout is 22.3 milligram per liter in previous example. So in exposure time of 96 hours, at the concentration of the 22.3 milligram per liter, 50% of fish died. Now, NOEC is the measure of no observed effect concentration. There is no observed effects concentration, and you can see in aquatic invertebrates, in Hieronymus, this is a non-biting midge, the NOEC is 0.1 milligram per liter. NOEC is always smaller than EC50. Here you see it is 0.46 milligram per liter. You see, NOEC is always, LOEL is the lowest concentration. So I put in these definitions on the other side, so we'll let it sit there for some time for those who will be looking at the video. There are ways and methods to calculate this, but these are the important measures for toxicity. So in water, The units are usually in milligram per liter, and it is the concentration in the water itself. It's not the ingested dosage. Another important measurement is predicted no effect concentration. This is a very difficult thing. If you want to predict a concentration that has no effect, you have to be sure that you have measured, for instance, no observed concentration like algae growth inhibition in fresh water and in Daphnia and in fish. And you see you have all kinds of different measures because every organism reacts the same. The toxicity measurement is usually done on some standard organisms, but this does not mean that, for instance, another algae, not the one that was used in the test, would not react more sensitively. So what you do is you look at different organisms and see what kind of responses they had. And then you take the organism with the most sensitive response of those that you measured against the one with least sensitive response and say, this is my assessment factor. So Daphnia versus algae is 10. This means that then you take the lowest value divided by assessment factor and have this predicted no effect concentration. So in this case, for instance, and to be sure, you can always take a bit more conservative measurement. The bigger the assessment factor you postulate, more sure you can be that there will be no problems. Oops, further reading. I assembled a bit of literature for further reading. You can take a screenshot and have a look at it. So now we come to more details and to the homework of this predicted.
Ranka, you have a question from Georg.
Yes.
Sorry, it's nothing. Just proceed. It can be talked about at the end.
Okay. So the homework is use of plant protection product in aquaponics. I will be going through a PDF file with instructions. And as I said, your mission today, should you choose to accept it, is to assess whether your chosen plant protection products are potentially dangerous to your system and how much you can apply without them being dangerous for your system. You will get the PDF file from Zala after the webinar. There are tables that you have to fill in and mail your solution complete filled in PDF to Zala. So I will share the exercise. Share. You see this?
Yes. Maybe just turn off the function with the dots. The one that it's in paragraph, that it makes it... Yep.
So this is introduction to the exercise, which you can read again. I said there are some data sheets where you have no environmental data in it. Here is an example in German. I mean, it is section 12, as always, ecotechnology, ecotoxicology, toxicity, Acute toxicity fish, no data. Crabs, no data. Algae, no data. Other organisms, no data. And again here. So you will find data sheets with no data when you do this exercise. So this does not mean that you found a data sheet with no data and you don't do the exercise. You go and look for another data sheet that has data in it. So first you check your national legislation. Task is add a link to your national legislation and write which country it is. That's the first step. You need to see what is allowed for organic or IPM, integrated plant protection management in your country, and you should put in these links. Second, you look a substance. Therefore, you look for a substance that you can buy, find a local supplier, and you find the substance that also has section 12 filled in. So download the technical information sheet, section 12 should be filled in, not one without data. Okay, there is some literature again, sorry. So you need to use this usually you will have LC50 or LC50, and you will usually use safety factor as no L. You can have a look here, one example, data extracted from a data safety data sheet of product natural by Andermatt biocontrol. It has also another work, and you can look this safety data sheet there. So this is section 12. And you can see fish toxicities 45 milligram per liter, invertebrate toxicities 23 milligram per liter, and there are some other risks. So your task is fill the empty table with a product of your choice. Waiting time, for instance, is very important. No? You need to know how long you have to wait. If you spread your salad, your lettuce or your tomato, that you don't eat it immediately, but maybe in 2 weeks. So if the waiting time is 2 weeks, this is not a good solution for lettuce. Oops. Sorry. Fill in the table. And now we come to the most critical step, estimation of critical mass of system loading. Here is an example. Again, for natural, you will need a volume of your aquaponics system in liters of the entire system. But if you use hydroponics, you can use also that. You estimate the no observed effect level for fish. That would be in this case LC50 through 100. And then this means that you can calculate the critical mass of system loading. Your critical mass of system loading is the volume of your aquaponic multiplied by NOEL concentration. So that would be 1.98 grams. So much product you can use in one application or altogether until your system is loaded to a concentration that will become dangerous for your fish. Now you can also recalculate this per application. prepare a spray in 2%, then you add the number of hydroponic area to be treated, and then you see hydraulic load of the prepared spray. You have to look at the technical information. You need to use 1000 liter per hectare. That's 0.1 liter per square meter in this case. Then you calculate how much spray mixture you will need, how much product you have in sprayed solution, and then you estimate, this is very important, the fraction of spray mixture that enters the system. You would say, I am very, very, very cautious. I spray only the top leaves. I put protective measurements, some protective foil so that product does not enter the water. And then I say, well, if I maybe just 10% of spray mixture, I might estimate, will enter the system. This means that you can apply 66 times on your hydroponic this product until you reach this critical mass of system loading. This sounds very complicated now, but it's actually very simple. You just have to sit down in peace and calculate. You won't need more than 2 hours for this whole exercise, but you might need 2 hours, but maybe you need only 1 hour. So your task is to take your other product, not natural, but another one, and calculate the critical mass loading, a number of possible applications up to critical level for your system. If you do not own an aquaponics, you write in some other, for instance, you make an assumption and calculate with that. Okay, this is the homework and we are finished for today. So now we can really discuss, we can try once again that Albert tells us about his work and then we can have a discussion. Zala, you are the boss.
Albert, can you hear us?
Yeah, I can hear now. Okay.
Then we try with presentation again. Ranka can share it. Albert, can you see it if Ranka is sharing the presentation?
Yes. Okay. Can you hear me now?
Yes.
Yes, we can hear you.
So the slide that we are looking now is
Okay.
objectives of the project. Albert, do you see that?
Yeah, yes. The objective
Okay.
of the project. Most of the project I've implemented. The objective was to improve food security and nutrition of vulnerable communities, to build the capacity of community and government staff in horticulture, to reduce the use of pesticides. You know, pesticide is a big problem in Africa. People are misusing pesticide. And also in different projects, what we try to do, FAOs try to sign like partnership with universities. So the young graduate of different university. So I try to mentor the research work, then to collect the data, and also to insert the data into Otiva. Also, I help them to do some publication. And if you see, most of the projects that I've implemented of the FAO, we share the data of production with farmers all over the world. We have all the data, production. We also have the data of, I don't know, if you go in the program Otiva, you can also select which cultivar you have. Let's say I have a cabbage that I grow, let's say in Senegal. I know the name of the cultivar. I know all the information, technical information, the amount of seed that I use, the spacing, the amount of water, the irrigation, all these components. And what we also do, for the sustainability of the project, before the project finish, we try to establish partnership with local non-governmental organizations because they are the ones to work to continue the project. Okay, can we continue? Hello, Ranka?
Yes, now you have
Hello?
the slides on implementation.
Hello, can you hear me? Hello?
And he's gone again. Ranka?
Yeah, I don't, yeah, let's continue. I'm truly sorry that this doesn't work. I think Albert tried the best what he could do, but the connection with Cameroon seems to be very bad. Are there any questions?
Yes, there was from Georg. Georg, do you just say what you wanted to ask?
Yes, I can do that. So my question is, Ranka, do you have any experience on the integration of habitats for antagonists in aquaponic setups? So, for example, that you build lacewing houses or integrate banias hedges around your facility in order to heighten or enable populations, for example, lacewing or Ichneumon wasp.
No, we did not do that. I mean, we buy wasps, don't we, Zala?
Yes, but I mean, we have the commercial production and
We
commercial.
use commercial products from. We have usually a consultant from Andermatt who
Hello?
comes and tells us what to use. Other questions?
Now also Albert is back again.
Yeah, I will try. Okay, Albert?
No, he's gone again. Ranka, I think we have to stop trying.
I think so too.
Georg, but you also ask about the water, right? So you have two different things. You can use the pest control like IPM, what Ranka was mentioning before. Meaning you're using, for example, ladybugs and so on, which are quite easy to get even on the other markets. But then when it comes
Hello, can I continue?
Yes? I'm sharing
Hello?
your slide. You have to talk.
Hello, can you hear? Okay, now I want to speak about the implementation strategy of most of these projects in horticulture. What FAO tried to do is to establish a demonstration center where we are going to train the people. So we use the farmer field school approach. So we try to, it's not the school like in the university. So our school here is on the field. So where we and the farmers, we try to record everything that we are doing on the field, from the seedling to the harvest. So we try to be practical. And what we are doing, when we train the people in the demonstration center, when they graduate, we give them a kit so they can go and establish their own project. What we try also to do is to raise awareness among national institutions. And also, the most important is to establish the partnership for sustainability with local NGOs. Sometimes we also group of women who are very well organized. If you see the next slide, you are going to see a type of demonstration center that are set up in different projects.
Yes. So I can just show the slides.
Can you put the next slide, please?
I did.
Yes. Okay, like this one, it's a training center. If you see, this one was done in Namibia. You see, Namibia is a desert country where water is a limited factor. So what I did in the training center, I tried to introduce drip irrigation and to show to people that they can also produce vegetable using very little water. And this is the type of research work that I've done with young graduates in partnership with the University of Namibia. We introduced hydroponics because so water is scarce. When you discuss with people in Namibia, if you ask them, why can you not set up your garden? They say, we cannot afford for water costs. So with the research work that we have done with University of Namibia, we show to people that you can produce one lettuce using 3 liters of water. So we try to do research work that we can use, that anyone can use. And this data of the research work, we publish the data and also we share it with farmers. If you see here, the first one on different hydroponic to compare different systems, here on the floating, and the second one on the sand, the river sand. The other one also, we use also different substrate using nutrient solution. We also use vermicompost, and also we use the sand. Then we compare the yield of different.
I think I will just show the slides. You can see Albert has ample experience, and I'm truly sorry that he cannot have a good connection to tell us more about it. This was really bad luck. But I will stop sharing now. So, is there any additional question? Is everything clear?
Yes, Georg was asking about more about the IPM and also how to disinfect the water, for example, if this is the case. So IPM, Ranka, I think she told a lot. There are also people that, for example, put bird houses around their systems or gardens to attract birds, that they would eat insects afterwards. But when it comes to the water disinfection, if you have a problem with pythium, the best way to control it is to keep your water temperature low if possible. But this unfortunately doesn't work if you have catfish or tilapia in the system. But in aquaponics, disinfecting the water, it's, I would say, a no-go, while in hydroponics, yes, it's often done. However, at least according to all the research, when it comes to infections in the aquaponic systems, there are much lower rates compared to hydroponics, because you have a really good microbiome in the system and you have a lot of good bacteria, so the bad ones do not have so much space and time to cause a lot of damage. While in
they are outcompeted, so to say.
Exactly. While in hydroponics, especially if you keep the sterile system, if you get something that it's a problem into the system because there is nothing beneficial inside the system, then you have a huge problem really fast. Hopefully this helps.
So, if there are no additional questions, we see each other in 2 weeks. I thank you for your attention. And yeah.
See you then in 14 days, and you get an email from me with the homework. Thank you very much.
Thank you. Bye-bye.
Thank you. Bye.
Bye.